The first two methods are used for adding items to a set, and that is add and update. So in this case here, we use add to add a single item. To update, you pass in an iterable, and we'll add those both items here. So in this case, we're adding x, here it is, and in this case here, we're adding 4, 5, and 6. The next three we're going to look at are all about removing items. So I've got a similar set, and I'm going to try and use .remove of ABC. And there we go, so we have DEF left. If I try and do remove ABCD, we're given a key error here. So just something to bear in mind, when we're using .remove, if the thing you're trying to remove does not exist, you're going to raise a key error. On the flip side, discards doesn't do that. So in this case, I've asked it to remove G. There is no G in the set, and we don't get anything back. So just something to bear in mind, key error for this one, no key error for that one here. And finally, we have .clear, which is similar to how you'd see it for a dictionary in a list. It simply removes all the items, and you're then given an empty set at the end. The last two I want to look at for this section is .pop, and just like I'd imagine this for a dictionary or a list, this removes and returns an item. However, in this case here, because we are popping from a set, we're popping a random item. So in this case, we've popped true. True has been returned to this variable and printed here, and then my set now only contains A, B, C, and D, E, F. And then last but not least, I want to show my set.copy. And again, similar to a list or a dictionary, it returns a shallow copy. So if I print my set and then new set here, we'll see them both. However, say I then come along and do, let's do my set.add, and let's add 0 to this guy. We only add that to our original set. The shallow copy is not affected by anything we do to our original set. Next up, we have our 4 set operations. And those are union, difference, intersection, and symmetric difference here. Let's go through them one by one. So starting off with union, the union is simply merging of both sets together here. So let's just quickly comment out the ones we don't need for the time being and take a look at union. We hit run. So 0, 1, 5, 6, 10, 20. Bear in mind any overlapping elements, because sets can only contain one of each item. The 6 here, nothing really happens. We're not adding 2 6s there. So the union is just merging of both sets. Next up, we have the difference, and this is basically one set take away the other here. So we're basically saying from set A, take away set B. So if we look at what we're left with 0, 5. So let's see what's happened there. We said from 1, 0, 5, 6, take away 1, 6, 10, and 20. So we got rid of the 1, we got rid of the 6, so we're only left with the 0 and the 5 here. So basically set A, take away set B. The next one is set intersection, and this is a little bit like union, except it's a bit stricter. And what this will do, this will basically say, only give me the elements that exist in both sets. So 1 is in both sets, and we have 6 in both sets, therefore the intersection is 1, 6. And there we go, just like that. Symmetric difference is basically the opposite. We're basically saying, give me the elements that only exist in one of the sets, but not both. It's like the unique order, the XOR operation from logic gates. So 1 is in both, so we don't count that. 10 is only in 1, 20 is only in 1, 0 is only in 1, so we're going to have 0, 10, and 20. And let's have a look, we also have the 5 as well, but yeah, because 5 only exists in A, that's not in B. If we come along and add 5 here, 5 is no longer unique, therefore it's not in the symmetric difference. One thing we also have as well is intersection, difference, and symmetric difference update. And what this does, this is effectively the same as what we've just seen, except it'll update a set in place to now have the intersection difference or symmetric difference. So we take the first one, for example, here. We're saying set A dot intersection update of set B. So we take a look. That basically now just means that set A is now going to be updated to just have the intersection. And then the same is then true for the difference update and the symmetric difference update as well. So key thing here is that these don't return a new set with the intersection or so on and so forth. They're updating an existing set to say, right, this set now contains the intersection of itself and something else. We hit run, we can see those 3 working there. And there we go, just like that. The next 3 we have are checking for subsets, supersets, and a disjoint set here. So in this case here, let's start with the top one. So let's see if letters A is a subset of letters B. In this case, it is. So we're saying, are all of A, B, and C in this superset here? Let's suppose we remove C, for example. Let's get rid of that comma here and try this. It's no longer false, yeah. So it's no longer a valid subset, so this is now set as false. Let's go and try the opposite of that, which is the superset. So in this case here, we say A is a subset of B, so therefore B is a subset of A. And there's a method for checking that, which is the other way around. So letters B is superset of letters A, and we should get true. And then finally we have a disjoint set. Sets are disjoint if there's nothing in common between them. So we hit run. These are false because, yeah, these sets have things in common. They have A's, B's, and C's. Let's suppose I did 1, 2, and 3. These are now disjoint because they have no common elements, and therefore the disjoint returns as true. Cheers for watching, guys, and I'll see you next time.